Bildschirm zur Stage hinzufügen.
Test, test. Yeah, sound is working.
Vorsicht. Konsole? Ja, wäre es. Test, Test, Test. Ich habe nicht daran herumgespielt. Test, Test, Test. 22 Sekunden.
We have some technical difficulties. Please wait a little bit. Mic batteries are empty. Wow. Ist jetzt der Auftritt?
Überhaupt nicht.
Das sollte jetzt sofort funktionieren.
Test. Sound test 1, 2, 3.
Test, Test, Test.
So we can start. So we have there still seats available in the front. You don't have to stand the whole session. Good. Sorry for the short delay. Welcome to the December 2025 .NET Community Austria event here at Linkholders. Thank you all for joining here in this quite hectic time before Christmas. Yeah, Linkholders, thank you for hosting.
Some short introduction from them.
Yeah, thank you so much.
We are glad to have you here today. Today nothing went according to plan. The guy that should stand here instead of me is not here due to health reasons, and I don't know anything about all of this technical stuff works, but I hope we set up everything right. If you're thirsty, there is a fridge behind you. You can grab some drinks. There will be pizzas in about an hour, so I hope you feel very well. Also, shout out to everybody at home. And yeah, have a lot of fun. Thank you.
Thank you. Yeah, thanks again also to our other sponsors, Rubicon and JetBrains. Rubicon supports us financially, JetBrains with a 12-month product license that we will raffle at the end of the session. To take part of it, please simply enter hashtag JetBrains in the chat. Makes easier also for the people here that you quickly join there, and that not the persons who already won multiple times JetBrains license. So if you already got something in the last 12 months, let the others have fun. Yeah, quick community news. Plan for the next meetups. January 2026, next year, 19th or 20th. Will now Alex Tissons talk about Testcontainers. Perhaps you noticed we switched January and December from the old plan from the last time. Yeah, that's happening 19th or 20th. In February, we have still Patrick and Tim with evolving modular monoliths with architectural fitness functions. At TechTalk, and in March, we have Shahab with Kafka through the lens of .NET. Yeah, if you
Just one question, how can we participate
in the chat in the chat of the stream? Yeah, YouTube and Twitch. Sorry. Yeah, if you want to host a meetup, we are always looking for hosts. So come to me, come to Raul to talk if there's an opportunity at your company. And with that, I'm handing over to Christoph, and we'll quickly switch HDMI cable.
And we should be good to go. Like I said.
Depends on the HDMI part.
What the hell? What did just happen?
Okay, this time.
Screen sharing. Good to go now. Perfect. So good evening, everybody. Welcome to the last meetup of this year. We are going to be talking about something that is near and dear to my heart, that is kind of feeling good about deploying to production. And that means you should be having a test strategy that makes you feel good that whenever you go and deploy something, that it actually will work in production. So there is only one thing I want to really make sure. I'm showing Testcontainers today, but those are not the silver bullet. My project from last year is different from my project this year, and it's totally different from your projects. So really depending on what you're doing, Testcontainers really is a tool that you should be using when it is useful. It's not the one single thing that will make your project immediately successful. It can be super useful. It can be the wrong choice, depending on your project. I can give you an example, where unit tests are simply better than anything that would be done with integration tests. So really, it is a tool in your tool chest, and make good use of it. That is the intent of this evening, to give you an idea of what's going on. Now, about me, the link I already posted into the meetup, so you don't need to take a photo, basically go back to the meetup page. There you can find the slides, the samples as well. I've been doing this now exactly 25 years, a quarter century. That kind of is bad when you're talking about .NET and doing it 25 years. I did a couple of books, luckily long time ago, can't recommend that at all. I'm still proud to be an individual contributor, so I'm still writing code. And one thing, and that's how I stumbled onto Testcontainers, is I'm always looking over the fence to other frameworks, to other programming languages, to see what they are doing and what, if any, of those patterns, techniques, tools they are using might be useful in our ecosystem. And kind of that is how I stumbled onto Testcontainers and where and how those can be useful. So the test pyramid, story time. I had an enterprise architect descend from the ivory tower, descend on me actually, in this case, who said, hey, all we need is unit tests, code coverage, and a nice KPI dashboard, and the project will work perfectly well. I was like, have you ever looked at the project that we are currently building? That unit tests won't cut it because we would be mocking away our main dependency. What on earth is this going to buy us when the like statements don't work, the transactions don't work, the query performance doesn't correlate to anything similar? So I had that fight just not too long ago, and it keeps coming up. Kind of, oh, what exactly is a functional test? What exactly is the kind of distinction to an integration test? What is an end-to-end test? You can have hours and hours of discussions that kind of remind me every single time of tabs versus spaces discussions when it comes to source code. So for example, the entity framework team calls theirs functional tests. And really what is important is that you kind of take a look at your application and find out what application type you have and to see what kind of tests you actually might need. So where do test containers actually make sense? And why on earth do they make sense? So if you've ever written integration tests, the number one first intent might be, oh, let's install SQL Server on the CI server. That's kind of the first thing that people get started with. And then they run that, and the more tests they add, the more interesting things get, the more weirder stuff gets in terms of, oh, why on earth do we have flaky tests? And then you find out, oh, wait a second, those guys are stepping on each other's toes depending on what's in the database. That doesn't work nicely. Then you find out that the test actually crashes and leaves everything in a totally unclean state, so nothing has been cleaned up. So that's a bad idea. Next idea you come across is, I'm going to use Docker. Then you find out, oh, the crash cleanup problem still exists. You still have the problem that you have concurrency issues potentially. And on top of that, you have a memory problem, most likely. So that's kind of when you start thinking, okay, now I have exhausted my wit and okay, there must be something that somebody thought about to make this happen. And that's basically what Testcontainers is. This is taken verbatim from the homepage. So I didn't kind of clean it up here. So we have those three ideas where they might be interesting. That is one thing, data access layer tests. That is kind of what most everybody is using it, interestingly enough. Then you can do UI acceptance testing using that. So think Playwright, for example. And then the number 3 item is application integration tests. And this is kind of where I would say today with Aspire, maybe that is starting to be the point where you will make a choice to say, okay, we are now getting into end-to-end tests, more or less. I need to stand up way more resources than I would like to. That's where when test containers are basically starting to break down. So it's clear cut for data access. That's a perfect scenario. And for most enterprise applications, that is really the sweet spot. Because what is an enterprise application doing? Modifying data. That's what it's doing. So that must be rock solid. UI acceptance testing in an enterprise app, most likely not. If you have a public-facing application, yes, that's a totally different story. If you're writing an application that needs end-to-end tests, like, okay, depending on the user that's being logged in, depending on the token, we expect different behavior and different code paths, then maybe only testing the database doesn't cut it anymore. Like I said, Testcontainers is a tool, and the tool might be a perfect fit in certain scenarios, and it might be a better thing to use for different scenarios. Now, Testcontainers was not invented here. That means it wasn't invented in the .NET ecosystem. And generally, that's kind of where you can find them. So an additional benefit is when you're talking to somebody from a different ecosystem, especially Java, they are using Testcontainers all over the place, even in certain scenarios like what we are using Aspire for today. So they are standing up the database and stuff like that, the dependencies, for their testing or their local development environment using Testcontainers. So they are very much used to Testcontainers and the concepts behind Testcontainers. So that might be in a multi-language team a good thing to go with Testcontainers. But the problem is, if you find some code in, say, Java, it doesn't mean it necessarily translates back to .NET, because those ecosystems are using different libraries and different feature sets. So something that works in Java that you have found a nice article, oh, you can do this, doesn't necessarily mean it works actually in .NET as well. I have an example for that. So be warned, that's not a .NET thing. Now, basically under the hood, what does Testcontainers do? It's actually very simple. It makes sure that when you start your test, there is the resource that you wanted, like the database, and at the end of the test, it tears it down. You can choose to keep it running, but the general behavior is at the test starts, the container starts, your test runs, the test container is being torn down. And if your test crashes anywhere in between, Testcontainers will take care of removing the container. So you no longer have the problem that you have a lingering container when your tests crash in between. So that's kind of what it's doing. If you have time, we can have a look at the resource repo, kind of the implementation that they're using, how to remove the stuff that's going. Now, you will find, if you go to NuGet.org, you find a ton of various containers. I have listed a couple of those that I think are somewhat commonly used, like Azure, so the Azure Storage Emulator, Postgres, MS SQL Server, Redis. So you find a lot of stuff in there, but not everything. So be warned. However, you can write your own. It's super easy because basically all you need to do is a couple of lines with the information. Okay, that's the image, that's the ports that are being exposed, blah, that's it. So, but in general, those are nice wrappers, and those do come with pre-configured image tags. So that means if you are upgrading one of those guys, and I will kind of getting back to that topic again, is if you're updating, you're also maybe updating, for example, the SQL Server image that you're using. So from, say, CU14 to CU18, for example, and we got bitten by that once. So that's why I'm very much aware of the problem. Please don't use the default tags that those guys are using. You will be surprised at some point in your life. So I have decided to stick with databases for the samples for Testcontainers. So obviously I need to cover two things. So why on earth, if I need SQL Server, why don't I switch out and go use SQLite? Or why don't I use the in-memory provider? Now, there's a nice talk that I'm going to link here, but let's get back to this. In-memory, what is the problem? If you take C# and string comparison, that's case sensitive. If you go to SQL Server, the default is case insensitive comparison. So that's the number one issue here. Number two issue that you will see is basically transaction support. That's different across all the providers. Then SQL Server also with the differing support for JSON, whatever. So if you go to a different provider like SQLite, also maybe not a very good idea. We tried at least the SQLite approach, and then a couple of months in, we decided to dump that approach and actually go with a proper SQL Server implementation. If you want the long version of that introduction, there's a nice video from the EF team from earlier in the year. Shai actually also did at the Update conference in Prague a talk in a longish version about how EF core kind of intends testing to be done against the database. But that is more or less the short version of that. So why unit testing doesn't cut it for the EF team, basically. Also the same why it doesn't cut it for me. Then he's going on in length why their tests, although they are integration tests with the proper database, take only 5 minutes. I'm going to touch on a lot of those points as well in parallelization, like cramming in as much as possible. And then a specific problem that they have is that they need retries in certain areas. So that's kind of the thing that needs to be spent a little bit with information on. So let's have a look here. This is the most stupid example I could come up with. This is basically everything in a super single unit test. I'm using XUnit here for a specific reason. I will get back to that reason in a couple of minutes. But basically what it does is you're using a respective builder. In this case, it's the MS SQL builder. There will be a Postgres builder, a Redis builder, etc., etc. That will give you the respective container. Then the container needs to start, obviously. And then the guy here has a couple of interesting helper methods on it. So it will give you a connection string immediately to the SQL Server database. In this case, it's the master database because there's nothing in there. And because there's nothing in there, I go to the master database and do a select one. That's basically all I'm doing here. Yeah, executing a scalar and then should be. Okay, I'm only going to run this one here because running the tests takes a bit of time. So, oh yeah, we don't need this, we don't need this. We need that guy. By the way, and that's one of the reasons I want to show this. Have you ever seen the nice containers view inside here? Because that allows you to dig into the respective containers. You get all the environment variables as well, of course. The very interesting password here. It as well allows you to dig into the files, into the file system. So if you want to find something, it's not super useful in the case of SQL Server, but if you have something that has stuff stored on the disk, you can actually go and investigate what's in the disk. So that's basically what I wanted to show. And yes, this, by the way, is using Podman. That's not Docker, just to prove the point. Although it's Dockerized and it's kind of, it's Testcontainers is for Docker. Nope, that works perfectly fine using Podman. And obviously, hopefully, yeah, that guy is green. So that is more or less the simplest thing you can do with Testcontainers. Obviously, it's totally pointless. Okay, we need to make this a little bit more interesting. And in this case, we are going to do one single test. Yes, I am really doing the stupid things here, like doing a string replacement for the master database, replacing it with my test database. And then, yes, I have static database operations that are really as stupid as they ever could get. Like, yeah, newing up the context, ensuring created async. Don't do that. That's demoware. But the point is here, actually, because that's checked into the GitHub, all the LLMs have learned my code sample. So be aware, if you ever get a stupid proposal from an LLM agent, it might be my code. So yeah, it does a couple of operations against the database, like inserting. So that's the classical blog and blog articles sample from Microsoft. I didn't do anything interesting here. But that is, again, just like, okay, now I'm doing something useful, doing my own database context, doing my own operations. Still, all the ceremony around it. So I'm kind of setting up the database, I'm starting the stuff, I'm disposing the stuff. And as the command says, smartly, don't do this. Because basically that means you're recreating a container with every test. It might be okay if you're running exactly one single integration test. Then yes, probably that would be okay. But in real life, that is totally not okay. Don't do that. Let's make this a little smarter. So we are getting in with IAsync lifetime in XUnit. That means I get everything that I need, like overrides for initialize and dispose, which basically make sure that I have everything in place. The MS SQL builder is now a field. The connection string is now a property that I can use. And basically, I have split up the previous example into kind of a sort of reusable code pieces for multiple tests. But still, if I write the second test, that basically means test starts, container starts, second test starts, container starts. So depending on the parallelization, I might even exhaust my memory, CPU, whatever. So still not a good solution, but we are getting there. Just to get an idea, and now it's nicely wrapped. It still has a don't do this here. But basically, I have moved everything outside. iTest output helper is an external library that allows me to write to the test output in Visual Studio, which is kind of nice to have. It's only added here. I'm creating an iLogger. Yeah, that's their functionality. And here you can see is basically I've listed the version of SQL. So you would be basically putting that in config somewhere, but that is kind of the way to say, oh, I'm locking this to a certain version. Yeah, this is the most important thing to learn about Docker images. Latest is not a version. You might be getting whatever is latest at that point in time. That's not deterministic for you. Better not to find out the hard way. Basically, yeah, that's kind of everything added to the outside. I'm not going to show you everything because there's a couple more tricks down there that we need later. But basically, now everything has been externalized and can be reused. Still, the thing is maybe a bad idea because I'm having a container for every test. So how do we actually go about that? Because if you do that, work log time will suck. So how can you make sure that when you're writing tests, that actually those tests are performant? That your team is not going to kill you because you killed developer experience, because your build now takes 2 hours. That's a bad decision. How do you get performance back? How do you get work log time back? So what can you do? I'm going to show you a couple of those things. Is like using respawn. If you haven't heard that, I'm going to show you. Make use of collections, for example, and make smart use of collections, because you can even optimize inside of collections to make that better than that. And if everything fails and you are still too slow, you can build your own container image. But that is definitely a last resort. I'm going to show you why. And yes, the homework link is then also part of that. So test containers. Away with that, and let's have a look at an even more complicated example. So that is, again, doing the stuff that is the stuff that you saw before, custom fixture with iHost. And then here's a test collection that is applied to any tests that you have. So basically you say, oh, I'm kind of sorting all the test classes into a test collection. And then I can make a smart choice. And here I have added a nice tip. If you have read operations, batch those read operations into a collection and parallelize the read collection, because the data is already in the database. You're not modifying the database. All the read scenarios can run in parallel as much as they want. They can't step on each other's toes. So that is a perfect example to say, okay, I'm taking every read operation that's needed for the database, put it in a separate collection. And that one needs exactly one database and parallelize the hell out of it. That is tip number one. Number two, if you're doing basically standard stuff where you have side effects, then you need to get really smart about the things. That is kind of what the tip below is. And that is kind of what I stole from Shai. You can start the transaction and use the transaction isolation of the database. And then even if you make database modifications, those database modifications are kind of serialized to your session that you're in. Nobody else will see those changes while those changes are in the transaction. And because I'm basically throwing away the transaction, it will be automatically rolled back at the end of the method. That means the test will run, everything in that synthetic transaction will do its work. When it's done, it will be rolled back and your database is still clean for the next test. So here you can parallelize write tests that way. Yeah, question.
Is this using the old system net transaction stuff, or is this?
That is basically entity framework.
That's okay. That's entity framework. Okay.
Yeah. No. I'm not using old stuff here. Well, I could actually, I should show. I hope I'm doing that. Microsoft, that's not in this guy. That's in the sample stuff to test. Yes, I'm actually always doing that here. Also a trick for you. Even if you're using Entity Framework SQL Server, that will drag in Microsoft Data SQL Client, it won't always drag in latest. And if you want the latest and greatest in terms of performance and security fixes, have an explicit reference to Microsoft Data SQL Client. That is what you can do here. Okay, so that is kind of nice ways of, okay, I could kind of have everything in a kind of non-parallelized collection. That is one option, like I had here with disable parallelization. That is one option. Then everything runs one after the other, and they don't crash each other's data sets. The other option to go is really say, okay, everything that is read is in a single collection, and if I want to fully parallelize write, I can go with transactions. So that is just the thing to do in this case. Yeah.
Is there any reason not to do it in the transaction?
If you are starting yet another transaction inside there, and you are using other isolation levels, then I might consider not doing it that way.
Assume it as the stuff you were using response, for example, to reset the data.
Yeah. So yeah, we can have a look at respawner we can have a look at respawner right now. Basically, that is what respawner does. Here I have a test that runs twice because the inline data is for 2 rows. And what respawner does is basically it's resetting the database. So it works perfectly well with temporal tables. So even those can be reset. The thing really is the more data you add to your database. So if you don't have a blank database, the more interesting it will get at some point. So that's the downside of the whole thing. So we have used respawner quite a bit. Yes, for certain simpler scenarios, it's okay. For more complex scenarios, I would go with especially pre-configured databases with data in them. So because we haven't yet really talked about that problem is there is a difference in behavior of your application if the database is empty versus there's already tens of thousands of rows in there. That will make a difference in the behavior of your application. So that means you can't, not like what I did in those cases here, those guys basically do a EF migration and you get an empty database. That's, yeah, not really helpful at all in most cases. But really you should be going and doing more interesting things. And that's when respawner can help to say, okay, oh, I'm making a checkpoint here, and then rolling basically the entire database back to what it was before. And that is kind of the homework example that I had, that basically does all the things more or less and hides everything that is interesting, like resetting the database and doing all the integration testing set up with everything in there. Because with that guy, you can even have mounts to the local drive and say, okay, I already have a Postgres file on disk, please mount that one. And that is kind of the starting point of the entire story. That is kind of what could be done. So that was not the son, but that was the guy. So 06. And this is kind of where we are now more or less at the full build out of the whole thing. We have a fixture, and now I'm going to show you the stuff that I kind of started hiding from you. I also added an iHost. So think of web application builder and you getting an iHost when you start running. And this guy is intended if you need, for example, connection strings injected or services injected, but you don't want the entire thing that you get from, let's say, ASP.NET and its test infrastructure. So that is kind of what I'm doing here. Getting the context, adding the DB context to the host builder services. And then I have my host in here. And down here, I can actually go into the DI container and grab stuff from the DI container. So this is now the part where we are kind of going from classical integration test to more of a full-featured end-to-end test, where we're getting into the area of, oh, maybe ILSpy at some point. If you set up your vertical slices for testing, this still is a very good approach. That works the way it is supposed to working. But as you can see, the boilerplate code gets a little bit nasty. You start adding stuff and you start repeating yourself. And there is a solution to this nice problem here. Yeah. We need the mic.
What's the difference between what you're doing here and web application factories?
Basically, I am only giving myself an iHost minus everything else that Web Application Factory also does. Because there's a lot more to the pipeline, especially in ASP.NET. And here I'm really, you can compare it to the console application host. That's more or less what I'm doing here. But again, it gets tedious and repetitive if you're doing everything on your own. And the fun part is, obviously, somebody else had that idea as well. And there is an Testcontainers X unit package that actually wraps all the goo that I showed you. Oh, you need to take care of starting. Oh, you need to take care of setting everything up with the collections, etc. And that is basically here the DB container test. And there are tests for a couple of types of containers. And here you can see basically it takes a builder as the first one, and then the actual class, that's the second one. And here in this case, I'm using Postgres just to show that it can be done with multiple different databases. And at that point, it starts to be opinionated. That means, okay, there is an override for a configure method where I then can say, oh, I want to configure the builder. And then the configuration of the builder that I want to be done happens in this configure method. Then you have another override for a DB provider factory that allows you to set the necessary instance, do again the initialization, and then you are into your tests. And that's basically, yeah, that's the code from the static operations. I decided to not rewrite the stuff that I had for SQL Server, also for Postgres, and copied the code. That's exactly the same code for the database context that I had for SQL Server. And that's doing the same things in here. And kind of taking the grunt work out of what I did before and kind of gives you the best practices already without you having to write those best practices yourself. And the DB container test, if I take a look, for example, F12, let's see. Oops, here we are. So it basically does the same stuff that I did manually, more or less. But my code existed before that, so at least I can claim innocence in terms of copying stuff from here. And that kind of does all the necessary things that you would be expecting. And then you have kind of a standard way of doing things in your tests. That's kind of the basics of database tests that you can build. Now, I said you can go overboard. One way of going overboard is, I have added that here, It's a super simple helper. That's the SQL Server Management Objects. That is also available as a NuGet package and allows you to take an export script from SQL Server Management Studio that is littered with Go statements in between. You might have seen that when you did an export, and then you can basically take that script from SQL Server Management Studio and immediately smash it into your database. So if you had, say, sample data in your existing database, you can generate the insert statements that way and then insert that as part of the initialize async method in there. Another way, which is slightly nastier, is to use a similar approach, but that time using the DAG services. And that allows me to actually go ahead and export a backpack, which is more or less a very portable database backup that I can later import. So the SQL package tool is very much the same, but this is basically the underlying C# implementation of the whole thing that allows you to take a database that you have created. Say you have a very longish setup that is necessary to add test data into your database. Say it takes a minute or so. Then it might be smart to actually go ahead and say, okay, now I'm setting up my entire database, and then I'm exporting as a backpack, and then when I need it later, I'm setting up a new container and load the backpack in there. Then I have an already migrated, already pre-filled database without having to do anything. And that is basically the simple approach when you're doing it inside C#. And you can go one step further. And that one step further is only for illustration purposes. You can go ahead, take the respective SQL Server image, install all the crap, and by the crap I mean the SQL package tool, and then take a exported backpack file and more or less whack it into the database. And once that is done, basically you have a proper image that you can start. So you would kind of do the Docker build step, push it to a registry if you want, or keep it local on your machine. And then you can say, okay, instead of starting the standard image for Testcontainers MS SQL Server, please use my own image that I just created and get going with that one. That means if the more complex, the more data, the more interesting those approaches are starting to get, where you have a separate CI step that basically, before all the integration tests, builds the SQL Server image with all the data in there, and then you can go ahead and use that image going forward. And yes, you can even optimize that further in that the CI server actually has the respective SQL Server images already stored in its VM image. So you don't need to download it from the registry from Microsoft, because those guys can get rather big. So yes, there is even one step further to get going and optimizing with those guys. I have added a few bonus samples. And one of those nasty bonus samples is I once had the idea, I would like to know the SQL statement that is being sent to the database from Entity Framework. How on earth can I get the real executed SQL statement? Okay, I started digging around, and then it happened on a talk at the Data Community Austria in January this year. Or no, it was last year actually. And by the way, highly recommended community event at the end of January. And they were talking about XE streams and how kind of you could tap into those and get information out of SQL Server in a streaming fashion, what SQL Server is doing for your current database connection. That is kind of super cool. And I thought, okay, how on earth am I going to do that? Started digging into X events and found out that the library is native C and super nasty, and started digging around and then stumbled on XE Lite, which is kind of a simplified version of the library, which more or less gives you exactly that. So whenever you're executing a statement, it will give you the actual SQL statement that has been executed. So how does that magic work? Yes, now we're getting into SQL statements that are really nasty. So you need, obviously, the connection. You need to have a database that has been created prior to that, and then you're creating such a event session for all the text. Set that guy up, then run a query. That was basically what I showed you up top, and then wait for that guy to actually send you the information. And because that guy isn't nice, we need to wait a little bit before we can actually kill that guy. So that's why the task delay down here is, I haven't found a way to actually make sure that it flushes immediately. But basically that's the idea. If you ever want to know the SQL statements immediately, and yes, sometimes that can be interesting, otherwise correlating using tagging in, say, entity framework for OpenTelemetry works, but then you still need to go manually into the query store in SQL Server and grab that stuff from the query store. And here you have an all-in-one solution that allows you to print the SQL statements as they have been run against the database. So that's a kind of a cool use case. And obviously, that's kind of mandatory these days. There has to be a sample for a local LLM. To give you an idea what that might be, first word of warning, Ollama isn't something you should be using in production. VLLM or others are very much better suited for those purposes of taking it for production, but still it works reasonably well in a testing scenario. However, the image is huge. In that case, really, you should have it in your own MCR or already locally on the machine, because otherwise the entire CI time is taken up downloading the image for Ollama. That's not so fun. And also, by the way, that volume mount where I'm loading the LLM to, if your CI server is ephemeral, that means after each CI build, it's re-imaged, then also that downloaded LLM model goes down the drain. Just a word of warning, you can make yourself very much unhappy by doing ephemeral CI agents with those big images. Basically here, I have the same as before, just not the SQL Server, but Ollama with a mount. I am then doing a super stupid Ollama pull to get the model and then test the model. Yeah, you can get the idea what is the answer to life, the universe, and everything. And more or less ignoring the response, because proper evals of what an LLM does, that is a really important thing to do properly. And that would be the better, bigger part of the entire code base of the test in here to do that. So if you ever want to do evals, I do recommend you at least start at this article to get an idea what that means, because you can't rely on a model doing the same thing today or tomorrow. There will be updates, there will be surprises. It's non-deterministic, it's statistical, that means changes are to be expected. So evals are super important and you should not skip doing it properly. Now, with that, let's have a further look at a few gems. I have the sticker, works only on my machine. This is what Testcontainers really solves. You take your dependencies, you stick them in a container, and everybody will get the same results. No matter how they set up SQL Server, how they set up Postgres, did they, for example, use integrated security, blah, 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 blah. All of those simple configuration drifts between developer machines, that's not happening. Like I said, latest is not a version. Please pin everything you do. Size matters. Have a look down here. If you have an ephemeral CI agent, you're dragging down 1.5 gigs for SQL Server, you might be unhappy. Doing the same for Postgres with roughly 400 megs, that's way, way quicker and way more interesting. General recommendation, use Postgres. That nicely fits with item number 4. SQL Server 2025, they again didn't care to release an ARM64 version, which is super annoying because I do have a HP notebook with a Snapdragon X in it, guess what you can't do? Test containers for SQL Server on that machine. It somehow works with Rosetta, but Apple already said that they are going to phase out Rosetta at some point. That means you're also getting to get the problem with test containers for SQL Server on a Mac machine at some point. So SQL Server doesn't really play nice in all settings with test containers, simply because of the issue what processor you have on your machine. Now, what I showed you today was the database and super simple stuff. Basically taking the Olama builder and doing only what Olama builder can do. PostgreSQL builder, what PostgreSQL builder can do. And all of those things using the public registries. So MCR for Microsoft, the Docker Hub, etc. However, that guy can do a lot more, like private registries. Then Docker hasn't to run locally, not necessarily. You can have that remote. You can reuse containers. You can keep them running after a test. You can do your own Docker files. I'm going to show you that. But the problem is, stuff that you find on the internet isn't necessarily available in all SDKs, and that is one point in case. The other point in case, I didn't go into detail when I showed you the LLM test, but I'm also referencing a GitHub discussion for that one, simply because stuff doesn't necessarily work the same in all places. So be aware, if you find, oh, you can build XYZ with test containers, go looking which language framework they were using. And then go hunting whether .NET can do the same. That makes one hell of a difference. And test containers are not necessarily always the best solution to the problem you have. One point in case that I stumbled on, that was specifically Azure Functions. So obviously, you could take the Azure function and stick it into a Docker file, and then have the Azure function running side by side with, say, Azure Write and whatever else it depends on. That you can do. Or you can stick only the dependencies in the test containers and run the Azure function as is. So I was kind of debating around, and then I decided, okay, let's go to the Azure Functions repository and have a look at their integration tests. And basically what they do is they are downloading the Azure Functions runtime, taking the project they have and running it locally with the Azure Functions runtime. They have written a nice wrapper to make sure that basically the teardown is being taken care of. So the life cycle that test containers usually would give you, that's being taken care of by that in a nice C# class. And then obviously that is kind of a point where you could say, okay, maybe in that case, Aspire is actually a better solution than using test containers nakedly, because Aspire does support Azure Functions properly. And that same problem goes for other tools as well, that they might be actually better suited and easier to configure and easier to run outside of a test container. And to give you an idea what that could look like with Azure Functions, I have one super simple Azure function that only has an HTTP endpoint, nothing to see. Forget about that guy immediately. And that is basically this guy here. That is also based off an example I found on the internet. That is basically taking a test containers fixture that is doing all the crazy stuff. And here you can see a lot more of what test containers can do. So we are no longer dabbling with pre-built stuff that we downloaded from NuGet, but actually we are now diving deeper into a nice Azure function where we have a common directory, where we have an integration file, testing Docker file, and then there's an interesting build argument. That is basically the thing that makes sure that test containers know how to tear down your test container when the test is done or failed or whatever. That is basically the guy that is doing this, and the Azure functional test, very much unsurprisingly, has that stuff up there. That is all the magic. Everything else is standard stuff that's for Azure Functions. And this way, we are getting a test container for our own code that we built ourselves. And now we can take our Azure function in the test container and write our tests against that running test container with my Azure function, step by step. That's what this guy is basically doing. And then, yeah, here is the creation of the thing, the create of the image, weight strategy, all that kind of stuff that's needed. And once you have all that, basically everything is hidden in the fixture, then you can go ahead and take a crack at calling that stuff. And that way you have basically done that. And here is the killer, obviously. If you go back and have a look at the Docker file, you're downloading the SDK, and then you're basically also downloading the .NET isolated runtime as well as a Docker image. So you're pulling down 2 images, and you're building that stuff and doing copying around. And that's why I said maybe possibly for the benefit of the performance of your CI system, it's better to not do that, because that will take a lot of time. So even on that super fast machine, it's taking a couple of minutes doing the whole dance, having that set up. If, however, your Azure function is, say, super complex and does hundreds of things, then maybe that's a price that you could be willing to pay. Other than that, you might be only really setting up test containers and doing what the Azure function teams is doing. So it's a trade-off. That's where I'm trying to get at. It's not always the single best solution to do everything. Oh, I have learned how test containers works. I'm doing everything with test containers. There is kind of a scaling function to this, where it's useful, where it starts to break down, where I'm going to look for different solutions that might be faster than what I get out of the box. Yeah, so the same goes for other stuff like wiremock.net, dev proxy. Those guys, really depending on your usage, how you have set up your stuff, it might be really easier to do that outside of the whole thing. So, in summary, it's a cool tool, but it is a tool. It is your decision whether the tool is useful in your application building efforts or not. What really is a selling point for me of testing with a real thing is that it gives me the confidence that it will work once I deploy it. If I go ahead and use unit tests and mock all the external dependencies, what I am testing is an if-else, but not the behavior, not the runtime behavior, especially of a database. You will never see problems with transactions, performance problems with indexes that are not appropriate. That is something that you will see with a properly populated database. And kind of a side note on this one, a properly populated test database means properly populated with test data and not production data. Please don't do that. So testability has been a boon on all the projects doing test containers. And yes, wall clock time for CI does matter. In the last big project, our goal was to stay below 25 minutes. And that worked, even that in the end, we had thousands of tests, integration tests in test containers. We were building 10 plus Docker images and stuff like that. And we started progressively adding more tricks that I kind of showed you today to really kind of keep it below the threshold of 25 minutes. So that's entirely up to you. And with that, test containers really are cool. They do solve a real problem. And hopefully it can solve a problem for you as well. Thank you. And here we have the man with the mic.
Yeah, hello. Actually, I've noted down 3 questions, sorry. But all of them are quite quick. First one, you mentioned that the different SDKs for different languages might sometimes differently behave.
Yeah.
Do they follow a similar approach like OpenTelemetry, that they specify out the API and this is just bugs, or is this more like...
they are really like what Microsoft is always doing when they are writing SDKs for different languages, that they are writing idiomatic SDKs for the respective languages. And they are different teams. So although it's called test containers, the Java team and the .NET teams that, first of all, they are proper OSS projects, and yes, they are talking, obviously, but they are totally separate teams.
Okay. Second question, you mentioned you use XUnit, especially because there's a special package for it. Do other packages for other test runners, specifically TUnit?
No. So the package that I showed, and I can go back a sec. Swoosh. And yeah, that would be this guy here. Microsoft, so Testcontainers, XUnit, this guy here. That is very much specific. It was a community contribution that was open for quite a long time, that pull request. And that is basically the only convenience package that is available for any of the testing frameworks. What I showed you works with all the testing frameworks. The only thing that is kind of a bit specific is that I'm already on the MTP platform here for this guy. So because if you had looked closely, you didn't see the Visual Studio Test package included in here.
Right, one quick last one. One problem I usually face with test containers in the past is that a lot of my builds are already running in a Docker container. You mentioned that you could start basically what you're using test containers for somewhere remotely.
Remote, yeah.
Would that solve the problem, kind of?
So you can either have Docker in Docker. That's one way of doing it. The other one that I kind of recommend doing is, especially for the way that we build the stuff, is our CI runners were Linux, with the main intention, basically, that the tests themselves would be running on a Unix machine. And that way, basically, the code is repackaged using .NET Publish into a Docker container, however, not published to a registry, actually to a local file that we can then upload as a build artifact. And because of that specific setup, I wanted to actually make sure, hey, I want to see my code running on Linux at least once. So that's why the tests themselves were running on Linux. So we had basically only one level of interaction. And that is actually where MTP helps a lot with, because that's a change in behavior, because that kind of injects the testing framework into your assembly. That means the tests do run in the target runtime. That means you can even have that in a Docker image properly running. So if you build your tests into a Docker image, those tests will be running in the Docker image using MTP. So that is kind of interesting. There was a talk from Jakub, I think, on MTP at the .NET Conf in November. And that's definitely highly recommended if you want to make sure that your test stability goes up and your test quality goes up. Because if you're doing the standard classic old .NET test, the .NET test runner is actually on a different framework than what your tests ought to be running.
All right, thank you.
Any other questions from the audience or from the chat? No.
I have a question about parallelization. Usually we use Web Application Factory, and we wanted to parallelize our tests, but our main problem is that sometimes we have external dependencies which we can't use a container for. And the main issue we have is when paralleling, all tests won't expect their own configured fake object in some way. Do you have experience with that?
External dependencies. Those are exactly those guys down here. So DevBlocks is kind of best known for Graph API, whereas WireMock.net is kind of a classical tool that you can use to actually have pre-recorded responses available for external dependencies. So instead of kind of standing up a proper mock of the external dependency, you can use WireMock to kind of say, okay, on port such and such, for those kinds of requests, I'm going to give you those kinds of responses. that would be an option. And then at that point, really, it starts to get interesting. And that's why I have the iHost in my example. There I could then just say, okay, those 2/3 of my application are proper real services. And then I'm injecting, for example, for an external dependency, a mock implementation into that guy so that I don't have to stand up kind of test containers for the externals. And sometimes I even might not have those externals.
Yeah. My question was, is it possible to configure? But I have to look at the libraries because I'm not sure. Do I have then to configure for every test a specific port?
You could kind of do recording. So a recording of requests. So take the real ones and turn them into fake ones. And that's only kind of 2 tools out of a lot of tools that you could be using. So I would need to look it up. I have an idea where the list is stored on my machine. But those are only 2 of those that, at least in the .NET space, are well known. There's also cloud native tools out there.
Thank you.
Which questions are also still open?
Last call.
Silence here. No, nothing on the chat. Then let's wrap it up.
That means you need my HDMI cable.
Yay!
Wait a sec.
We need waiting music. So, give me a click.
So, thank you, Christoph, for being here and sharing your experience with us. Always a pleasure. Thank you all for joining, and also thank you, Lean Coders, for hosting the event, and also to Rubicon and JetBrains, our sponsors. We quickly look at the raffle. So last chance to participate in it. I need some. This is the right. So, and let's see. So, Stefan X2C, congratulations. Please reach out to us at team@.netdevs.at and we will send out the voucher to you. And yeah, with that, see you next year. Bye.